All right. Today I'm going to lecture on um, the ideal gas law, and you get a kick out of this because I'm really bad with my tablet, and so often you'll hear me talk to myself. Um, and so here we go. But anyways, the first thing that we're going to do in this chapter is called the ideal gas law, and later on we're going to talk about how a real gas uh, is different than an ideal gas. Um, just kind of like the ideal man or the ideal woman doesn't really exist. It's kind of the same thing. We'll talk about that later. But anyhow, here's the ideal gas law. It looks like this. It's PV equals nRT. And it's this equation that has 5 variables in it. And so P stands for pressure. And we learned yesterday that there's 3 pressure scales in high school chemistry. There's atmospheres, kilopascals, named after Blaise Pascal, and millimeters of mercury. They used to measure gas pressure in something called a manometer, and it was filled with mercury. And I hope that we talked about that yesterday, but we may not have. Um, V stands for volume, but the thing that's crazy about the ideal gas law is that the volume has to be in liters. If it's not in liters, you have to haul out the factor label method and get it into liters. And so on the next slide, I'm going to review some things about liters. N is the number of moles of the gas. And again, the mole is the most important concept in all of chemistry. And again, the unit on moles is always MOL. R is called the ideal gas constant. It's a constant, just like pi is a constant. It's always 3.14159. It never changes. The problem is there are 3 values of R because there's 3 different pressure scales. And so you will not have to memorize this. It will be given to you on all tests and quizzes, and I'm going to talk about that on the next slide. And T is the temperature. But the temperature in this chapter has to be in Kelvin, the absolute temperature scale. So the temperature has to be in Kelvin. And remember, if you want to get to Kelvin from degrees Celsius, all you do is add 273. Um, so that's it. Now, next slide. I'm going to come up here and I'm going to start a new slide. And the first thing I want to talk about is volume review from actually chapter 2, because our book does everything that you need to know about math in one chapter to get you ready. But one of the things we learned in chapter 2 is that 1 milliliter is the same thing as 1 cubic centimeter. And we talked about that in chemistry. There's liquid volume units that are measured, like milk is measured in the English system in like gallons, or quarts, or gasoline is measured in gallons. We measure liquid volume differently than we measure solid volume in the metric system. But then we learned the beauty of the metric system is it's an easy conversion. We also learned that 1 liter was the same thing as sorry, here I go, got to get my eraser, and then I got to get my pen back. We learned that 1 liter is the same thing as 1 cubic decimeter. And then finally, we did this stair step thing. Actually, we didn't really use steps this year, but here's liter and here's milliliter. And so then we talked about, actually, we did it more like this. 10 to the negative 3 is milli, and 10 to the negative 2 is centa, and 10 to the negative 1 is deci, and 10 to the 0, 0 means no prefix, in this case will be liter. And so there is 1 1,000 milliliters in a liter. And that is the only thing that you'll ever have to do in terms of conversions is using that one and these. And why this is such an important conversion is that in the ideal gas law, the gas volume has to be in liters, but all chemistry glassware is calibrated in milliliters. So in a lab situation, you're always taking the volume in milliliters, but in order to use the equation, you have to be in liters. So keep that in mind. All right, now here's the craziest thing. I'm going to flip back and forth to this page in a minute. The crazy thing about R, the ideal gas constant, is there's three values, and I'm going to give them to you now. Value 1 is 0.0821 weird, funky units, atmospheres times liters over mole times K. Or R is equal to 8.31 kilopascals times liters over mole times K, or R is equal to 62.4 mmHg, that stands for millimeters of mercury, times liters over mole K. And the crazy thing is, I'm going to go up here and grab a different color pen. This is the value of R you have to use if the problem gives you the pressure in atmospheres. And this is the value of R you have to use if the problem gives you the pressure in kilopascals. And this is the value of R you have to use when the pressure is given in millimeters of mercury. And it's kind of crazy because there's three different pressure scales, therefore there's three different values of R. These will be listed at the top of the paper on all of your assignments, and it will be listed at the top of the test on your Chapter 11 test. You do not ever have to memorize these, but what you do have to know is when do you use 0.0821 and when do you use 62.4. Now, this is a very, very easy equation mathematically. What's not easy about this is that you have to set up a table and you have to go straight down the table. And I'm just going to flip open my PowerPoint, and I'm going to go F5, and I'm going to go to slide, I think it's the right one, 18. This is the first problem. I don't think this is the one I wanted to do. Hang on. This is the first one I want to do. It says, how many moles of a gas can be contained in a 1.44 cubic decimeter flask at 32 degrees Celsius and 93.5 kPa. Now, the first thing that I want you to look at is it says oops, that's the thing about this. It says how many, oh, wrong way. I think, hold on. This is the part I'm a little crazy with this thing. All right, let me do this. I want to go to slide 18. So I'm going to hit S5. Go to slide 18. Okay, here's my first practice problem. So how many moles of a gas can be now, I can't really write on here because when I do, it thinks it's a mouse, not a pen tool, but this is what you need to know. The volume is 1 cubic decimeters is a volume unit. This is V. 32 degrees Celsius is a temperature unit. Celsius is a temperature. This is T. And 93.5 kPa is a pressure unit. And so the first thing I want you to do, so I'm going to escape and I'm going to go back to here and I'm going to flip back and forth between these. The first thing that you have to do is I want you on every problem today to set up a table. So I'm going to grab my thing. And remember now, here's the pervert equation. See how crazy I am on this? All right, so I'm going to grab my pen, and I want a blue pen. And the first thing I'm going to do is I'm going to say, okay, I need to know what P is. I need to know what V is. I need to know what N is. Grab my eraser. Always fun when I'm playing with this thing. Um, this is why I'm never gone, because I hate doing this. I need to know what R is. I need to know what T is. Now, if I go back here, I'm going to flip back to this PowerPoint, and it says, okay, how many moles? So I don't know moles. So this is my question mark. How many moles? Um, and then the next number I see is 1.44 cubic decimeter. So for volume, I'm going to put in 1.44 cubic decimeters. And then the next number I'm going to see is 32 degrees Celsius. That's a temperature. So 32 degrees Celsius. And then finally, then I can move on, 93.5 kPa. So this is 93.5 kPa. Now you have to set up a table. There's a reason. All right, now we're going to march down the table. You ready? These two are in tandem. Now, I always tell the kids when you're learning to do your letters, I mean, here's P. Isn't a P a lot like an R? It's just that a R has an extra thing. Because this is in kPa, I have to pick, I'm going to go back, the R value that has kPa in it. This is the only one I can pick. This is the one you pick if the table shows pressure is in atmospheres. This is the one you pick if you're in kPa, and this is the one you pick if you're in millimeters of mercury. So because I gave you kPa, I have to do 8.31 kPa times liters over mole times K. Marching down the table. P is done. Now, the volume has to be in liters. Now, if I go back 2 slides, one of the things that you're going to see is that 1 cubic decimeter is a liter. So, marching ahead 2 slides. Look at me writing everywhere. Marching ahead 2 slides. A cubic decimeter is a liter, so I'm going to lightly cross this out and change it to L because a cubic decimeter is a liter. And then finally, temperature has to be in Kelvin, and hopefully you learned yesterday that the way you convert Celsius to Kelvin is that you add 273. So this is 5 carry nothing, 10 carry the 1, and then this is 305 K. And the first thing I want you to do on all these problems today is I want you to set up a table. Okay, I want you to set up a table. Now, the next thing I want you to do is I want you to do 9th grade algebra. Here is the ideal gas law. PV equals nRT, but the rule in chemistry is that you have to do the algebra first. So in other words, I'm going to grab a different color. We're trying to isolate N. We want to get N alone. So N is multiplied by R and T. So I'm going to divide this side by R and T, but there's a rule in algebra that if you do something to the left, you have to do the same thing to the right. And I'm going to toggle down here because it's going to take a little bit of space to do this. Come on, come on. I need you to come down here. All right, so this is what we know. We know that N is equal to pressure times volume over R times T. I go up to the table. What is the pressure? It's 93.5 kPa. What is the volume? I think it's 1.44 liters. Now remember, we never divide in chemistry. See how R is downstairs? We never divide in chemistry if it leads to an improper fraction. By the way, if this bugs you with the factor label method that there's nothing down there, I need to take my R value here and flip it. And what that means is mole times K comes up and 8.314 kilopascals times liter goes down. And the same thing, T is downstairs. So instead of putting 305 K on top of 1, I have to flip it over 1 over 305K, and something beautiful happens. I have a kPa on the top, a kPa on the bottom. I have a liter on the top. I have a liter on the bottom. I have a K on the top. I have a K on the bottom. And every unit has canceled except moles. And that's what we're solving for. And so you get out a calculator and you're going to type in 93.5 times 1.44 divided by parentheses 8.31 times 305, and then the calculator says, I'm pulling my calculator out, 93.5 times 1.44 divided by parentheses 8.31 times 305, and my calculator says 0.053121856 moles. However, this has 3 sig figs, and this has 3 sig figs, and this has 3 sig figs, and this has 3 sig figs. Interesting thing, you don't look at the sig figs when it's in Celsius, you look at the sig figs when it's in Kelvin. And remember, the sig fig rule for addition is you count decimal places. So this has none, 305 has no decimal places, it's good to the ones place. Now remember, when we count sig figs, this 0 doesn't count. And so the best answer for this problem is, as I go up here and extend this page, I always have to grab this. Whoops, I guess I didn't want to extend it that much. The best answer to this question is, oops, and see, that's what happens when I don't grab my pen tool. The best answer I'm looking for is 0.531, because I get 1, 2, 3 sig figs moles. And I start with this problem every year, and that is the answer. And you'll notice you're only going to get 5 problems to do tonight. And so you'll have the answers for all of them. Okay, next problem. I'm going to flip to the PowerPoint, but remember, PV, nRT. There are 5 variables in the ideal gas law equation, and you will always know 4 of them, and you're solving for the 5th. So here is my second one, and it says calculate the volume in liters occupied by 3.44 moles of neon gas at STP. Okay, so this one's kind of crazy. It's a good one. It says calculate the volume. So I'm going to put a question mark here. And they actually said in liters. And then if I toggle back here, it's 3.88 moles. So I'm going to do this. Whoa, that was not good. I need to go here. So this is 3.88 moles. And now here's the crazy part. STP stands for standard temperature and pressure. And so you have to have those memorized. Standard temperature is 0 degrees Celsius. I think we talked about this yesterday. They picked that because that's a temperature at which water freezes at, and the planet is covered, 72% of it's covered with water, and so it's very important to life, so we picked it. And standard pressure, now there's 3 standard pressure units. There's 760 millimeters of mercury, and that's an exact measurement. There's 1 atmosphere, that's an exact measurement, meaning it has infinitely many sig figs. And then there's 101.3, like KDWB, KPA, and it doesn't matter which one of these you pick because you will get the same answer no matter what. I'm just going to pick KPA. We just did KPA. I'm going to pick 1 atmosphere, and remember that's exact. So Average atmospheric pressure is 1 atmosphere. It's an exact measurement. It has infinitely many sig figs. Um, R is 0.0821 atmospheres times liters over mole times K. So here's what we do. If I pick this in atmospheres, I have to pick the R in atmospheres. Um, Make sure it's in liters. Well, we don't have to do that because we're solving for that. That's mole. And then temperature has to be in Celsius, or sorry, Kelvin. 273 plus 0 is 273 K. And so now I'm going to come down here and I'm going to do my PV equals nRT, the pervert equation or the perv nerd equation. I'm going to switch to green this time. I need to isolate P, which means I have to get rid of what's ever on P. Sorry, I have to isolate V, sorry. So I have to divide by P, but in algebra, if you do something to the left, you have to do it to the right. And so now I'm going to come down here and I'm going to start the problem by doing this way over here, because the rule in chemistry is that you always do the algebra first. V is N R T divided by P, but in our case, we're going to multiply by the reciprocal. So what is N? 3.88 moles. And if it bugs you that there's nothing downstairs, put a 1. Check. What is R? 8.3. Sorry, I lied. That's what it is when we're in kilopascals. I'd like to say I did that on purpose, but I didn't. R is 0.0821 atmospheres times liters over mole times K. And then check, what's the temperature? 273 K. If it bugs you that there's nothing downstairs, put a 1. Now remember, P is downstairs. Dividing by P is the same thing as multiplying by the reciprocal of P. So I'm going to go 1 over 1 atmospheres. Watch what happens. Mole cancels with moles, and atmosphere cancels with atmosphere, and K cancels with K, and nothing cancels with liters, which is awesome because we're solving for volume. So now I'm going to pull out my calculator. I'm going to go 3.88 times 0.0821 times 273 divided by 1. And my calculator says 86.963604 liters. This has 3 sig figs. This has 3 sig figs. This has 3 sig figs. This is definition. It has does not apply. And so we get 3 sig figs. And so the best answer is 87.0 liters, because you get 1, 2, 3, but this 6 is bigger than 5, so the 0.9 has to round up. All right, here is your last problem. So I'm going to go to the next page. And again, we're doing the perv nerd equation. So PV equals nRT. I'm going to go over. This will be easy on your worksheet because you could just pluck them off your worksheet, but I got to flip back and forth between. This says what pressure in atmosphere is exerted by 7.93 moles of a gas in a 205,000 cubic centimeter container at 8 degrees Celsius. So I'm coming over here, and P is what pressure in atmospheres. V is 205,000 cubic centimeters. And I don't even remember what N is. I got to go look. N is 7.93 moles. 7.93 moles. And T is 8 degrees Celsius. Okay, walking down. If we want the answer in atmospheres, we have to pick the R value that's in atmospheres, which is 0.0821 atmospheres times liters over mole times K. Check. Now, the volume must be in liters. The reason for that is you won't get a cancel. So if I go back to the volume slide, you will see that a cubic centimeter and a milliliter are the same thing. So I'm going to just mentally change 205,000 cubic centimeters to 205,000 milliliters. But now, using the stuff from chapter 2, we know that 1 liter is 1,000 milliliters. If milliliters on the top, 10 to the third milliliters has to go down. 1 liter goes up. Milliliter cancels with milliliters. 205,000 divided by 1,000 is 205 liters. So atmospheres, the pressure in atmospheres measures the R value in atmospheres. We've converted 205,000 cubic centimeters to 205,000 milliliters, and we've converted milliliters to liters. The last thing we need to do is to add 273 to 8 degrees Celsius, because it has to be in the absolute temperature scale, or Kelvin, or it doesn't work. So now we have a 281K, and now here's my perv nerd equation. Perv nerd, this time, switching colors, we're solving for P. So we have to isolate P. We have to get whatever is attached to P gone. So I'm going to divide both sides by V, and this cancels this, and you end up with P equals NRT over V. What is N? It's on the top. It's 7.93 moles over 1, because there is no up and down unit. What's R? 0.0821 atmospheres times liters over mole times K. Check, check. What is the temperature? 281K over 1 if you want. Check. And where is the volume? The volume is downstairs, so I have to multiply by the reciprocal, which is 1 over, because dividing by 205 is the same thing as multiplying by 1 over 205 liters. And a beautiful thing happens. I got a mole on the top, a mole on the bottom. I got a K on the bottom, a K on the top. I got a liter on the top, a liter on the bottom. Everything's canceled but atmospheres, which is cool because we are solving for pressure. So 7.93 times 0.0821 times 281 divided by 205. My calculator says that this is 0.89241 89902 atmospheres. But this has 3 sig figs, this has 3 sig figs, this has 3 sig figs, this has 3 sig figs. Best answer, 0.892 atmospheres. All right, last thing. You're going to get a worksheet called the Ideal Gas Law Worksheet, and it has 10 or 11 problems on it. I can't remember how many. I want you to do only 1 through 5 on the Ideal Gas Law Worksheet. And my expectations are table, algebra, plug and chug, meaning plug the numbers in and chug out the answer, and watch sig figs. And you guys have the answers are on your worksheet. So if you don't get the answer, ask me to work it on Tuesday when I get back. Have a nice weekend.